So sine, cosine, and tangent we've covered before. In geometry, we used it to solve for the missing sides and missing angles because we used inverse for a right triangle. But there are more triangles than right triangles because not every triangle is going to have a right angle and be a right triangle. So sine, cosine, and tangent also work for triangles that are not a right triangle because we can use them for any triangle. However, we have some specific laws for the ones that are not a right triangle. And the first one we're going to look at is law of sines. And I think we'll change it a little bit. We'll actually cover this the rest of the week. So we're going to spend 4 days on it. Law of cosines, we're not going to spend as much time on it because it's not as difficult. Not as difficult. There's less cases. Law of sines has a few more cases that we have to delve into. So law of sines. So we have this here, introduction. So in this section, we'll solve oblique triangles that are not right. Either acute, all three angles are going to be less than 90, or we're going to have one that's going to be greater than 90. And we have it kind of set up in this way. Now, there's 4 different setups that we can have. And we can have one where we have 2 angles and a side. And if we think of a triangle, if I'm given these 2 angles, well, the side's either going to be outside, because if I'm given this side, I have side, angle, angle. I'm not given that side, but I'm given this side, well, I have side, angle, angle. Now, we can also have the side in the middle, angle, side, angle. And you're probably remembering congruency and similarity. But that's not, we're not going to actually get too much into angle, angle, side, side, angle, side, any of those. It's just, this is one of the setups we can have. Now, the other setup is 2 sides and an angle opposite one of them. So we're given 2 angles and the side, or 2 angles and or 2 sides and an angle. I was like, wait, that's too similar to the other one. So this one here, we're given 2 sides and either this angle or this one. We're not going to get the one in the middle, but we're given one of the 2 angles. Now, if you remember back from geometry, side-side angle was not a congruency statement or similarity. It just didn't work because we could set up 1 triangle, 2 triangles, or no triangle. So this one here is really where law of sines gets tricky, is this case here. Both of these we're going to use law of sines for. Now, if we're given 3 sides or 2 sides with an angle in the middle, we're going to use law of cosines. So if we're given 2 angles and a side, or 2 angles and a side or 2 sides and an angle, we're most likely going to use law of sines. Now, law of sines, because I gave you a worksheet, kind of that flowchart sheet, up at the very top, there are 2 different versions of law of sines. Now, law of sines, one way is A over sine of A is equal to B over sine of B is equal to C over sine of C. Now, we don't use all 3. We use 2 of them. So if I'm going to solve, I would say I'd pick these 2. Or we could pick these 2 or these 2. Because we can pick any of the 3 to set equal to each other to solve for the missing side or missing angles. Now, the reciprocal of it is we just flip it. Sine of A over A is equal to sine of B over B is equal to sine of C over C. So we can use either one. Now, the method of which one, or kind of deciding which one I'm going to choose, is really dependent on what I'm solving for. So if I'm solving for a missing side, I'm sticking for this one here. If I'm solving a missing angle, I'm going for this one here. Because whatever I'm trying to solve for, I try to leave it on top. Because if you remember, we're dealing with fractions. If I'm solving for something on bottom, I've got to multiply, then I have to divide. I've got to do more steps. So I try to keep whatever I'm solving for on top of the fraction. Okay? Now, so the main thing for law of sines, and kind of to make sure using that table that we know it works, is we have a side and an angle opposite. If that's true, we're using law of sines. If not, we're going to be using law of cosines. Now, We'll eventually come back to using law of sines. Law of sines gets used in pretty much every single one. And sometimes we'll have to use law of cosines to get the additional information first. For the triangle here, side length C, or angle C is 102 degrees, angle B is 29 degrees, and side length B is 28 feet. Find the missing information. So what's given to us? Two angles and a side. So when we look at the flow chart that I gave you, two sides and an angle. Okay, that's what we have. Solve using number 2. So we're going to solve it using that method. Now, before we plug anything in, we can find one of the missing lengths, or one of the missing angles. Yes. Because one thing we do know about a triangle is that all three angles add together to be 180. So what we can do is I can take 102 and add 29 to it. 9 and 2 is 1, carry the 1. Yep. Yeah, and if we subtract it from 180, we get 49 degrees. So that's what's kind of nice with this here when we're given two sides and one angle, or two angles and one side, is that I can find the missing angle. Because if I'm given two angles and I'm only missing one, well, we can add those two other angles together and subtract from 180 to find the missing angle, which we find out is 49. That's not bad. That's nice. Now we just need to find the missing sides. Now the second method was A over sine of A is equal to B over sine of B is equal to C over sine of C. Now, we don't use all three. We just use two of them. Okay? So let's see what we're given. Well, we're given so B is 28, yes? Over sine of 29. I mean, we could use A or C, but really at this point you need to pick your poison. Because we need to find what? All of the missing measures, all the missing sides and angles, yes? So that means I'm going to have to find A, and I'm going to have to find, so we're going to have to do both. We just need to pick which one we do first. So we can find side length A first. Since we don't know what it is, we'll just leave it as A. Now we're going to put it over sine of what? 49, because the side opposite side A is 49. The angle opposite is 49. So we have this here. A over sine of 49 is equal to 28 over sine of 29. Any questions on this so far? Now we just need to get A by itself. So I can multiply both sides by sine of 49. Well, these would, so I would have A by itself. And A is going to equal 28 sine of over 29. And when you plug it in, so at this point, we just plug it into the calculator. You need to make sure the calculator is in what? Degrees. Yep, so you need to make sure, because most of this chapter we're going to be sticking in degrees, not radians. So menu, or mode for the graphing calculator. And it should be, yep, enter, yep, and then you can do second quit, yep. You're welcome. 41.59 if we round up.
Yeah.
40.
43.59.
Yep. And that's it for side length A. Questions on this here? We good with this here so far? Yes? Okay. Now, okay, we did that to find side length A. Now, what I'm going to do is going to do something similar, but we're going to find side length B. So we're going to have B over sine of 102, because that was our angle, is equal to. Now, we could pick A or C. It doesn't matter which side length we pick. But I'm going to keep with the same one, because I said 28 is what we used previously, yes? Over sine of 42. 29, yes, thank you. I'm going to use this, and there's a reason for it, and we'll see it here in a minute. So we're doing the same setup. The only thing I really changed was what? This angle here. Because everything else is the same, because this is one of the side lengths. Now our next step is going to be almost the exact same. I'm going to multiply both sides by sine of 102. I mean, last time we multiplied by sine of 49. This time we're just multiplying by sine of 102. Which will tell me that B is equal to 28 sine of 102 over sine of 29. Now, you already had most of this plugged into the calculator, didn't you? Because in the calculator, memory is up top, isn't it? So if you cursor up and highlight that and hit enter, it'll bring it down. It'll copy it back down. That's why I used the 28 over sine of 29. I already have it in the calculator. And I can replace the 49 with 102, hit enter, and it'll tell me that this is what? 43.59, not 53. But that's it. And I used B for some reason for that one. I just realized it's C. But it's the same type setup, same type process. And that's it. That's all we have to do for this here. Questions on this here? We good with this here so far? Okay. Yes. And it does seem a little bit more complicated than what it is. It's just that we have so many different ways that we can have this set up with A, B, and the sides and angles that are given. I wanted to give you a way that will systematically break it down so that you will know exactly what you're given. Okay? All right.